Okay, we are moving into the next application of right triangles. In your learning target today, you're going to be able to find sine, cosine, and tangents given segments, angle measures of a right triangle. Our topic is really SOHCAHTOA, but I spelled it wrong. Gosh darn it, I forgot the H for so. So it's so, like S-O-H, ka, C-A-H, toa, T-O-A. And we just watched that video that is connected to the acronym that helps relate segments given an angle measure. First off, you need to understand what trigonometry is. If you look at that prefix there, that trig is a study of triangles. Which seems like, how much do you even need to study for triangles? Well, trust me, if you start studying triangles in the field of trigonometry, it's very advanced. It's not just that they have three angles that add up to 180. It's not just the trigonometric ratios that we're going to be dealing with today. You delve much deeper into it, but it's all based on the simple little triangle we learned back in kindergarten, right? When we talked about shapes and stuff, and we just keep getting deeper and deeper into it. I have a lot of visuals here. I'm just going to guide you through. You're going to pick your favorites. Everyone's going to have something else that they like. This is just a way for you to identify the trigonometric ratios and being able to identify adjacent, hypotenuse, and the opposite. Okay. So theta is an angle measure. It's like x, but we typically don't say x for an angle measure. For an unknown for an angle, we call it theta. Theta is just like solving for x. It's just with different ratios. So theta is an unknown given an angle measure. And if we're looking at this theta, which connects these two segments, then given this, the opposite over here doesn't touch the angle theta. Hypotenuse is always opposite of 90. So you find 90, go opposite. That's the hypotenuse. And adjacent is the segment that's sticking to the angle. So adjacent is sticking to it. And you might even want to write that, sticking to angle. And maybe you sometimes forget that the hypotenuse is always opposite the 90. Okay? So adjacent's always sticking to it. The hypotenuse is always opposite of the 90 degrees. Theta, an unknown angle measure. So here if I have theta, well, theta's on that top right there, then what's adjacent to theta is the segment that's sticking to it. Notice adjacent, it's sticking to the angle. Hypotenuse is always opposite the 90 degrees. Here's my 90 degrees. Hypotenuse is the segment after it. Just again, this is just visuals, so you can identify adjacent, opposite, hypotenuse. So let's say that my angle is right here. Here's theta, some random angle. Adjacent sticks to theta, but hypotenuse is sticking to theta too. It's just hypotenuse is opposite the 90 degrees. That's how you can always tell the difference. Hypotenuse is always opposite the 90 degrees. Okay, so again, this whole page is just kind of defining things. Theta, adjacent, hypotenuse, opposite. Notice opposite I never even talked about it. Opposite does not touch theta. Here's my opposite, I didn't touch theta angle. My opposite on this first one didn't touch the theta angle. More visuals. Okay, this is aligned. I don't know, I think our notes are slightly different, but it's okay. Theta is an angle measure. Sine, here, write this down. SOHCAHTOA. I don't know if you have it on yours. But so means opposite over hypotenuse. Cosine, ka. What do you think the A stands for? Say it.
Adjacent.
Yeah, so this is adjacent over what?
Hypotenuse.
Hypotenuse. Tangent, what's tangent?
Oh, a tangent is opposite over adjacent.
Okay, TOA, it's TOA, which is opposite over the adjacent. Again, those are all just ways for you to remember. The biggest thing that you will use a lot is SOHCAHTOA. You are going to use that a lot. If you can remember that acronym, you will always be able to set them up right. As long as you remember hypotenuse is opposite 90 and opposite segment doesn't touch the angle you're referencing. Okay, more visuals. So here's my theta. Sine of theta is your opposite over your hypotenuse. Cosine of theta, that's CA. So it's my adjacent over hypotenuse. Tangent of theta, that's TOA. So it should be my opposite over the adjacent. Just more visuals for you. Do you have this one, sine 35 somewhere?
Yup. Yeah.
Okay, so what is sine 35?
Ooh.
So here's what I write down. Here's my process. I use my acronym. Sine is the S, so it's so. So I write so. So I'm dealing with opposite in hypotenuse. So I should write op in hypo. That's what I write. I abbreviate, obviously, otherwise you're going to be writing a long time. So looking at my 35-degree angle, what's opposite of 35? What doesn't touch it? 2.8. Over, what's the hypotenuse? Yep, 4.9 because it's opposite the 90 degree. So it's 2.8 over 4.9. We're going to go ahead and turn those into a decimal. And that's 0.57. So 0.57. I want you to see how to use this with your calculator. You have 4 problems that you need to use your calculator to find it. So I want you to find the trigonometric ratios, but it's not obviously a ratio, it's just sine, cosine, tangent. Find it on your calculator. Mine is right a row above my row of 7. Sine, cosine, tangent. And I want you to write down in your calculator sine, you hit the sine button, it says sin, and then it gives you parentheses, you type 35 and equals, and hey, it gives you the same thing. Because it is such a popular concept with right triangles, and you're going to be dealing with them quite frequently as you go up in your math. Okay? I want to pause for a minute, make sure you know how to get there. Once again, another visual to help you. I personally, this is my preference visual. It's like a distance triangle. Sine for so is opposite hypotenuse. Opposite over hypotenuse. Cosine, is adjacent over hypotenuse. And tangent, is opposite over adjacent. I really like that visual. You're going to be able to do it whatever works for you. So let's apply the trigonometric ratios and find cosine of C. Also cos, some people say cos, but I want you to get used to the actual vocab words before you start abbreviating. So cosine of C, well that's ca, right? Ca, so toa. And ca would be adjacent over hypotenuse. And I gotta find C, here's C. What's adjacent to C? 4. 5 is the hypotenuse, so we don't use 5. So adjacent to C is 5. Hypotenuse is opposite the 90-degree angle. And, 4 over 5. And I'm going to say leave it as a ratio if you can. Sometimes you have to turn it to a decimal, like the first one that we did, because it was 2 decimals. But if you can leave it as a fraction, leave it as a fraction, okay? So, and then the best thing would be cosine C equals 4/5. It doesn't matter if you do that or not. Tan of B. So I'm going to find B. B is right up here. Tan TOA. So I like to write what it means, TOA. So it means I'm going to go opposite over adjacent. Opposite of B is what?
Ooh, 5.
5. Yep. So here's B. Opposite is 5. And what's the hypotenuse?
13.
Yep. 13. Wait, I don't want the hypotenuse showing me. I want adjacent. I know that's what I asked. I know that's what I asked. That's because I'm so used to the hypotenuse. Adjacent, what's sticking to it? 12. 12 is sticking to it. So it would be 5 twelfths. So tan of B equals 5 twelfths. Okay, next one, sine of theta. So I find theta, here's theta. Sine is so it's S-O-H, so. Opposite over hypotenuse. Opposite of theta doesn't touch it, so that's 6. Hypotenuse, opposite the 90 degrees, that's 10. And then you simplify your fraction, 3/5. So sine of theta equals 3/5. And then again, you have some other homework today, like 4 problems where you have to use your calculator, where it says find sine of 72. And you would just hit sine or sin in your calculator, sin 72 is equal to 0.95. Round to the nearest 100 when you use your calculator, okay?
Oh, okay.